At the end of this online module, you should be able to reference an array using appropriate indexing, specifically linear indexing, and replace elements of arrays. This module is concerned with replacing elements of an array using linear indexing. There's another very similar module concerned with replacing elements of an array using array indexing. Let's consider a problem to explore replacing elements of an array using linear indexing. An engineer is working on the design of a treadmill and needs to better understand the speed at which users start their workout. Distance and time data have been provided for 2 users using a treadmill at resistance level 7. The engineer had assigned the dataset on the left to a matrix, but then realized some of the elements were not correct. The engineer would rather fix the incorrect values in the MATLAB code than enter the whole matrix again. The table on the right contains new values to be replaced. We will use linear indexing to replace the values in the left matrix with the colored values in the right matrix. So, what is linear indexing? Let's look at a theoretical array. Linear indexing addresses an element in the array using a single value. Notice how the elements of the array are subscripted. The single value, or subscript, is determined by counting down each column, then moving from left to right. When you want to use or refer to any value in an array using linear indexing, you need to make reference to the location of the values of interest using subscripts. For example, say we have assigned our data for our problem to a matrix. How would I reference the value of 3.0 in the last column? I'd have to use the variable name for the array, user_data, and supply the position number of the element 3.0. When I begin counting at upper left, I start at 1 and end at 6. The second column counting takes me from 7 to 12. The third column counting takes me from 13 to 18. Then finally, the fourth column counting starts at 19 and I end at my desired value at position 20. Therefore, the MATLAB command for identifying the value 3.0 is user_data, open parentheses 20, close parentheses. Linear indexing, as opposed to array indexing, is often used with vectors since there is no second dimension to worry about. In this column vector, we just count down the first column, ending at the last value, as there are no other columns to the right. Here's an example when the vector is a column vector. What is the linear address of the value 20 in user1_dist? The value 20 in the vector is the third element, so the MATLAB command is user1_dist, open parentheses, 3, close parentheses. It works the same when the vector is a row vector. The indices just count from left to right because there's only one value in each column. So, what is the linear address of the value 3.0 in dist1_time1? The value 3.0 in the dist1 time 1 vector is the fourth element, so the MATLAB command is dist1_time1, open parentheses 4, close parentheses. In MATLAB, I have entered the original data in a variable named user_data. It is a good practice not to overwrite your original data, so now I will create a copy of the original data variable. I'm going to call it user_data_rev for revised. Now, one of the goals of the problem is to replace the value 5.1 in the position 8 with the value 4.9 highlighted in yellow to the right. So I reference that location in the revised variable to assign it to a new value. I do this by typing the name of the array and referencing specifically the 8th position in parentheses. Then I assign it the value of 4.9 by adding the equal sign and 4.9. When I press enter, the new array has the value 4.9 in the 8th position. Next, let's replace the green values in the third column. Since I am replacing a continuously indexed set of values, since they are all in the same column, I can index using the first index to be replaced, then a colon, and the last index to be replaced. I am replacing values at indices 13 to 18, so I type the name of the matrix and index using 13:18. 13:18 is a vector of length 6, so I need to replace it with a vector of length 6. Finally, we need to replace the block of values in orange at the right. In this example, the linear indices of the values I am trying to replace are 4 to 6 and 10 to 12. Indices 7, 8, and 9 are skipped. Let's see what happens if I try to replace the 4 to 6 and the 10 to 12 indices at the same time. This error is telling me that the size of my replacement array does not match the size specified by the indices that I entered. That is because I used the syntax in MATLAB for array indexing rather than linear indexing. This code asks MATLAB to replace the 3x3 block of the matrix that is the 4th, 5th, and 6th rows and the 10th, 11th, and 12th columns. So this method did not work. One way to use linear indexing is to replace each chunk that has continuous indices separately. So I will replace the 4th through 6th elements using one command and the 10th through 12th elements using a second command. Alternatively, I can do this easily in one step by using a vector input for all the indices that I want to replace. Here I have gone back to the version of user_data_rev that didn't have the orange values at the right replaced. Now I will enter user_data_rev, add one vector with all of the indices 4, 5, and 6, and 10, 11, and 12, then set that equal to the replacement values in vector form. You can see this allowed me to use linear indexing to replace all of the values in one step. To summarize our module, we learned that we can reference elements in an array by using linear indexing, using a single number position to indicate location. This is counted down the columns, then moving from left to right. For vectors, the elements are more commonly referenced using linear indexing. Finally, linear indexing is very useful when replacing one element or a set of elements that are continuously indexed.